Good morning to all. Myself Priyanka Devendra Lanjava, Faculty of CSE Data Science, RCPIT Shirpur. So today we are continuing our second lecture on the machine learning 3. So in the first lecture we already covered the elements of the RL, what is RL, elements of the RL, reinforcement learning versus supervised machine learning, and today we are discussing the remaining part of the first unit. So we covered what is machine learning, then the types of machine learning, then what is reinforcement learning. We covered the different components of the RL, that is elements of the RL, that is value based, model based, reward signal. So we covered this reinforcement learning, differences and supervised learning. So today we are going to cover the different approaches of solving the reinforcement learning. So mainly it will categorize into the three different categories, that is value based, policy based and the model based. So what is value based? The value based is the approach or the method to find the optimal value function, which is the maximum value at the state under any policy. So therefore the agent expect the long term return at the any states under the policy pi. So it is the approach or the method to find out the optimal value function. So next one is the policy. As we already discussed, policy is nothing but the approach or the strategy we are following in the environment to get the reward. So policy based approach is to find the optimal policy, to find the optimum strategies over there to get the maximum or the optimum result. So we are getting the maximum future reward at the end without using the value function. In this approach, the agent tries to apply such a policy that the action performed in the each step helps to maximize the future reward. So we are distinguish the policy base into the two different categories, such as deterministic policy and the stochastic policy. So in the deterministic policy, the same action is produced by the policy at this state. And what is stochastic? In this policy, the probability of the probability determines the produced action. So next is approach is the model based. So in this approach, the virtual model is created for the environment and the agent explore that environment to learn it. So there is no particular solution or the algorithm for this approach, because the model representation is different for the each environment. As the environment change, the model is changed. So there are three approaches, that is value based, policy based and the model based, to solve the different RL problem. So next is that, so exploration and exploitation dilemma. So let's first discuss what is exploitation or exploration. So exploitation and the exploration are the key concept in the reinforcement learning, which helps the agent to build the online decision making in the better way. So in reinforcement learning, whenever agent gets the situation in which they have to make a difficult choice between whether to continue with the same work or to with the same policy, or to explore something new at a specific time at a specific state, then the situation result in the exploration or exploitation dilemma. So the agent has to choose between the exploration, whether he is trying for the new policy, whether he is trying for the new approach, or continuing the same one or the previous one. So he has in a dilemma situation, so he has to choose between two, that is exploration or the exploitation. So because the knowledge of the agent about the state, action, reward and resulting state is always partial. So exploration and exploitation are the method for building the effective learning algorithm that can adapt and perform optimally in different environment. So there are two examples we are seeing here. Advertising. So in case of the advertising, exploitation shows same profitable advertisement repeatedly. This is the exploitation, that we are showing the same advertisement repeatedly. And exploration means showing the new advertisement which may be more some profitable. And in case of the restaurant, exploitation means going for the same dishes or going for the same favorite restaurant, and exploration trying out the new restaurant and trying out the new dishes over there. So these are the examples of the exploration and exploitation. So the exploitation means is the strategy of using the accumulated knowledge, as we already discussed, to make the decisions that maximize the expected reward based on the present information or the previous information. The focus of exploitation is on utilizing what is already known to the agent about the environment and achieving the best outcome using that information. So the key aspect of the exploitation include the reward maximization, as we know that our ultimate aim is that, or the agent ultimate aim is that he need to achieve the maximum reward over there. And next is the decision efficiency. Exploitation can often make more efficient decision by concentrating on known high reward actions, which lower the computational and temporal cost associated with the exploration and the risk aversion. So these are the key factors associated with the exploitation. Next one is or we can say the next one is the algorithm included in the exploitation. So the common algorithm included in the exploitation is the greedy algorithm. So the greedy algorithm tends to choose a locally optimal solution at the each step without considering the potential impact on the overall solution. So this method greedy approach is the follows the exploitation method, as it continues the same approach or the same policy throughout the environment and achieve the rewards. So next approach is the exploration. As we discussed, in this approach we are exploring the new actions, we are exploring the new policy. So we are doing this to increase the knowledge, to increase the resources about the environment or the model. So the information process select the action with the uncertain outcome to gather the information about the possible state and reward that performed action will result. So these are the key aspect, the information gaze. So we are by selecting the exploration method, we are acquiring the new information, we are gathering the new information. So that's why the information gain we are doing over there. Then uncertainty reduction. So after selection of the exploration method, we are reducing the uncertainty present in the model. Then state space coverage, we are covering the large space over there. So especially with those large or the continuous state space, we are selecting this exploration rather than the exploitation. So the strategies include in the exploration, that is epsilon greedy exploration, which is the advanced or the updated version of the greedy exploitation method. So this is the epsilon greedy exploration. We are adding the new term, that is epsilon word over there, and making the exploration method. So epsilon greedy algorithm manages to unify this two characteristic, that is exploration and the exploration, by something choosing completely random action with the probability epsilon, while continuing to use the current base action with the probability 1 minus epsilon. So if we are choosing this epsilon greedy, we have two options, that is with the epsilon or 1 minus epsilon. So next is the Thompson sampling. So this algorithm is also comes under the exploration strategy. So it exploit the Bayesian method to explore or exploit services simultaneously. So at the last, there is immediate RL. So as we already discussed what is RL, so reinforcement learning is the method where the agent has to perform different actions over there through the different states and achieving the results, or they are getting the rewards over there. So what the immediate terms added over there? So immediate means we are achieving the reward or we are receiving the reward immediately by after performing the action. So that's why immediate reinforcement. So it is the variant or the extended version of the RL where the agent receives the feedback, reward or the punishment immediately after the each action rather than after the sequence of the action. So this immediate feedback allows the agent to adjust its behavior promptly, facilitating faster learning and more efficient decision making. So the immediate RL involves agent receiving reward immediately after the each action, shaping quickly decision making. So these are the characteristic of the immediate RL. So the instantaneous feedback we are receiving at the end after the each action rather than the complete sequence of the action. Then simplified decision making is there, or with the help of this we are selecting the exploration or we are solving the dilemma of exploration and exploitation method over there. And the application where this immediate RL is used. So in case of the drug testing, as we know in the pharmaceutical research, the IRL, that is immediate reinforcement learning, can model the processes of testing various drugs or the microorganism. So each action aids an immediate reward, which is effectiveness, which allows the effectiveness, allowing researchers to quickly identify effective treatments. So in case of the robotics also, we require the immediate feedback, we require the immediate reward. So it applied, so IRL can be applied in the robotic control system where the immediate feedback is crucial or important or required for tasks requiring rapid adjustment such as emergency stopping or impact prevention. So this approach enables robot to quickly react on the different actions. So these are the two applications. We have the lots of applications of the immediate RL also. So these are the course outcome which is mapped with the unit number 1, that is CO1, that is to analyze the basic and advanced reinforcement learning techniques. So thank you. So after this we will continue with the, or we will start the second unit, that is immediate RL. So we are going to see the detailing of the immediate RL in the second unit. So thank you for attending the lecture.